Hello, class. I wanted to go ahead and go over graphing a line given its equation in standard form. So we're dealing with a linear equation again here, and the standard form is ax plus by equals c, if you're working with just the standard form. But again, we're graphing a linear equation, so all we need is 2 points. So there's a couple different options for this one. If we want to just find 2 points, two of the easier points usually to find are the y-intercept, where it crosses the y-axis, and where it crosses the x-axis, or the x-intercept. So if you're finding the y-intercept, that's going to be the ordered pair, where the x value is always 0, and then we need to find the y value. So remember, this is our x and y. It's a y. And the x-intercept is going to be where y is 0. So the x-intercept, or sorry, the y-intercept, the x is always 0 because we don't want it to move left or right. We just want it wherever it's going to be along this y-axis. That's going to be our y-intercept. Same idea with the x-intercept. We want it to be on the x-axis, so we don't want it to go up and down at all. So that's why the y is 0, and we'll just find the x value. So what we're going to do is we're going to take our equation, negative 2x plus y equals 2, and we're going to plug in or evaluate for x equals 0. And then that will tell us what y equals. So I get negative 2, that's multiplication there, so that's times 0 plus y equals 2. Now, when we have anything times 0, we get 0. So this just tells us y equals 2. So one of our ordered pairs is that when x is 0, the y value should be 2. Okay, so there's one ordered pair. Same idea over here for the x-intercept. We have negative 2x plus y equals 2. We have the same equation. We're still working with the same equation. And what we're going to do is plug in 0 this time, but for y. So I have negative 2x plus 0 equals 2. And that gives me negative 2x, because if you add 0 to anything, it's just what you had. And then to get to our next step, we're going to have to undo multiplication, and we use division here. So we get negative 2x divided by 2 equals 2 divided by negative 2. Sorry, I forgot the negative 2 over here. We're dividing by negative 2. We want this to become positive x equals 2 divided by negative 2 is negative 1. Okay, so we end up with the second pair is negative 1 comma 0. So when I plugged in 0, I ended up with negative 1. The other concept is what we've worked with before, which is using that y equals mx plus b. So we can graph these 2 points and get our line, or we can use the y equals mx plus b. So let's look at this as well. So to get this, we need y by itself. So here we have to add the 2x. We're moving the whole term over. We're not just getting rid of the negative 2, dividing that over. We're moving the whole term. So we'd get y by itself equals, put it in the order you want. You would want it in 2x plus 2. And what we've talked about before, the y-intercept is always your 0 value, comma, whatever the number is you have here in the back once you have it in the proper form. Notice that that's the same point we found the y-intercept. Shouldn't be different. And our slope is 2, and we can always put that over 1. So we just have to use our slope to get to the second point. Okay. So these are going to be two options. Let's graph our 2 points from our first option. So 0 left and right, up 2. Okay. And then our next one is -1 left, up and down 0. Okay. So that gives us our line. Trying to draw it perfect so that when we go for our slope, you can see what's going on. Okay. So that's option 1. Option 2 would be you have 0, 2. That's your first point. It's the same point. Now, +2 and +1 mean up and right. So I'd go up 2, right 1. And you see we're still on the line we already drew. It's just a different point than the other one. So there's points all along this line. You just need to find 2 of them in order to get to your line. All right, let's look at one more that's a little different. Okay. So again, we have a line that's in standard form. So we can go the same route as we can work with the y-intercept and x-intercept. The y-intercept is where it's going to cross the y-axis. So the x value is going to always be 0 on those. So you don't want it to move left or right. You want it to stay on the x or y-axis. Same idea for the x-intercept. Your y value is going to always be 0 because you don't want it to move up and down. You just want it to know where it is left and right. So we have x minus y equals 3 for our equation this time. Plug in 0 for your x. Sorry, I stopped a little early. So we have 0 minus y equals 3. -y equals 3. Now this means that there's really a -1 in front. So to get rid of that, because we want a positive y to get our y value, we divide by -1. And that gives me y equals -3. So when x is 0, y equals -3. Okay, let's go over here and we'll find the second pair. Same idea. This time we're plugging it in for our y value. So we have x minus 0 equals 3. X equals 3. So our x-intercept is 3, 0. All right, so if we plot these, we have our first ordered pair, which is 0 left and right, down 3. So 1, 2, 3. And then for our x equals 3, we have x equals 3, y equals 0. So 3 to the right, up and down 0. And connect your dots. And then you could also do this one with the slope-intercept form if you wanted to get it into the y equals mx plus b and then solve from there. That would be another option. So let me show you an Alex. So we have the points 0, -3, and 3, 0. So 0, -3. and 3, 0. There you go. All right, I hope that was helpful getting you going on graphing a line given its equation in standard form. Again, you can use the two ordered pairs or you can put it into slope-intercept form. Have a good day.